we have to simulate because for saturation we normally need 24 hours, so we have to put the sample and wait 24 hours for saturation, then another 24 hours for consolidation, and then go to break the sample. So as we do not have enough time, we are going to just to start, see what happened, and go to the next step. So, and now, for example, we are going to try to do a saturated sample. And to saturate, we can go here to see configuration. We press here, and we have CD, collapse, compression, custom, odometer, permeability, CR, consolidation A, consolidation B, consolidation A, okay, consolidation B. Saturation A, saturation B. Okay. First thing we have to do is to saturate the sample. To saturate the sample means that we have a sand. Between the sand grains there is a hole, there's a space, and water can get inside. And we need to fill with water the sample. The sand maybe now I have 10% humidity, but can get 15%, I don't know. So we have to fill with water the sample, and this means saturate the sample. To saturate the sample, we have to put some pressure surrounding the sample and put some water on the bottom or the top of the sample. The water gets inside. You have to keep a difference between inside, outside the sample for 24 hours, and after 24 hours, the sample is full of water. One time that you have finished the saturation, you have to consolidate. Consolidate is reduce the size of the sample. You have to remove out the water that you don't need. So the lateral pressure is increasing, the sample reduce a bit the size, and the water come out. So to start saturation, you can do in two ways. Possibility one is this. Everything is what we call saturation B. I can put pressure control 2, sample bottle pressure value 6, pressure control 1, lateral pressure value 6.2. This means that I am going to take a sample, I am going to put 6.2 pressure surrounding the sample and 6 bar inside the sample. And I have to leave this for 24 hours. This is one standard. A second standard tells you that you have to do it step by step. Is this. Here you see that we have a value of 6, a value of 6.2 for lateral. In this case we have for lateral pressure, first step is like a consolidation but do it with water. First step we only have 0.5 and inside the sample 0.05. The second step you keep the 0.5 and the next step you put 0.4. The next step is 1 surrounding the sample and inside is 0.4. The next step is keep 1 and the other is going to be 0.9. You always are increasing the pressure, first lateral, then inside the sample, and always keeping a small difference. You need to keep a small difference to get the water inside of the material, because if you have surrounding pressure very high, the water cannot get into the sample because of this, it's compressing. So you can do the saturation following option A or option B. It's your decision to choose one or another. In the case of consolidation, you also have this B. B is a coefficient that is calculated and helps you to decide if the sample is saturated or not. It's the difference of pressure. So you can activate this and the software will stop it automatically, the test at the end, or you can simply wait 24 hours. That is what people normally do. And when we consolidate the sample, suppose that this had been for 1 day with 6 inside, 6.2 outside. If we go to room and consolidation, we keep in 6 inside of the sample, but the lateral we increase to 6.5. As before we have 6.2 and now we have 6.5, we compress the sample and the water gets out. And we have to keep another 24 hours and the sample is finally consolidated. Problem that I have now. Now I have a problem because I am using number 1 red to do a triaxial. And I have created a test that I call it the saturation. Yeah, and I'm using pressure control 1. I cannot because it's used. So what can I do? I can modify. So I can go here. This is the saturation test. Custom test. Saturation. Here we have all the steps. Here we only have 2 steps. So I can go here, for example. 2 is okay. 3 is going to be 3. 3, 3, 3, 3, 3, neutral, automatic, by the way. And now I have pressure control 2 with 6 bar, bottom. Pressure control 3 with 6.2 bars, lateral pressure. Everything is right. But see that we have 2 and 3, and here we have 1 and 2. So I have to go here and select 2 and 3. I press Control, 2, 3. Update, and it's ready. 2, 2. Sorry. 2, 3. 2, 3. 2 bottom, 3 lateral. The test is ready, so now we can close. Remember that is the last one. Saturation B. Okay. I can go to saturation B, right button, so play, I press, and the pressure control 2 and pressure control 3 is going to try to get 6 and 6.2. 6 has to be on the bottom of the sample, in 6.2 is going to be surrounding the sample. 1, 2, 3. 2 is 6. So this is going to be surrounding the sample or in the bottom? Bottom. Wow. This one is lateral pressure. You see this and this and this and this is on the top of the sample, and this is on the bottom of the sample. Okay. So we can connect here, or also we can connect here, because what we want is to saturate the sample, and we can use the top or the bottom. It's not a matter. So I am going to put it here and ready. Second, this is the lateral pressure, so this goes here. You want to know. Okay, now before I start the saturation, we are going to give to the sample 2 different pressures. One surrounding the sample, one inside the sample. The first always must be the surrounding, because if you put on the bottom, you can start to put. So this is green, so green, I can open the ring. This remains closed, so this is not a problem. We still have 0 bar, so we can open this. And pressure control 3, I can deactivate. You see how the green is moving. This is air, and this is air that was on the tube. Something that we have to do, and I haven't done, is to remove the air of all tubes before start a test. It's always very important. Where is CD? This CD. Well, now we are going to simulate a saturation. Then we will simulate a consolidation, and then we decide what we can do. Now the lateral pressure, interstitial pressure, then the most important is that we have to keep a difference from 0.2 to value the water gate inside of the sample. This goes down because inside the sample we do not have pressure, and now it's going to increase step by step, step by step, and at the same time it's going to get water inside of the sample. So we can close. And if we want to run a test, set the X 50, 100, blah blah blah. And continue. Now we have started the saturation of the sample.